Good night, Jermaine.
Good night, sir. And yes, I did the homework.
All right, guys, check out your homework in the meantime for me, please. Homework on desk. Homework on desk. All right. Let us speak. Good afternoon again for those of you who joined after I told you good afternoon. Let us see if we can go through those questions. I would love to move into another aspect or the two aspects of the integration. So let us see. Were we able to do the assessment, the homework?
Yes, sir.
Nice.
Most of it, sir.
Yes, sir.
No, I didn't get to do two, sir.
So that's all right. At least you gave me an attempt. All right. Oh, sorry. Let me disconnect this one. Okay. So let us. Is there anybody in a position to share? Anybody wants to do the question for us instead of me doing it all the time? Do I have a volunteer to share? If not, I can go ahead and do it.
You're unable to share tonight, sir?
No.
No.
No, man, I can share. It's just that I thought to myself that every night me alone I share. So
It's good to share.
All right, sir. You put up the screen and we talk to you and tell you where to write.
Or allow somebody to control the screen if it's.
No. As I said before, I'm in a position to share. I can share my screen. It's just that I thought.
You don't have the software like you.
Oh, yeah.
Right. We wouldn't have
Yeah, fair enough.
good up things like you.
Talk truth.
Oh, sir, I mean, you're the weapon for each class.
Absolutely.
Then if I did know, I would have tell us I'm come long time make it.
No, man. I was giving. No, I mean I came on like 5 minutes to 7. Jeremy was here, so I was giving the others a chance to get in, and it's only 14 of you guys are here. So, all right. So let's go. Let's go. All right. What was the first question again? Because I don't remember. Give me the first question on the list, please.
Was that one of the questions?
X squared
No.
plus 3x.
X squared
Sir,
plus
that is it, sir.
Yeah, that look like it.
All right. X squared plus 3 is all right. Okay. So let me project what it is that all right. My answer is 74/3 unit squared. All agreed?
Yes, sir.
Who disagree? Talk to me.
For
So
me,
we
it's
can go
slightly different.
Talk to me. Very good.
We get a big number. Oh, you break it down more. 148/6. That may have.
Yeah, that's fine.
Oh,
Same
yeah, that's
difference.
what I got to. 148/6.
Oh, you're fine, me, sir. That may have said.
Let me put on my glasses, sir. Come here, sir. Not again.
Yeah, man, you're good.
Sir, so I won't lose any marks if I leave it at 148/6.
No, I wouldn't penalize you. I wouldn't penalize you, but I'm just going to say to you that always try to get it in through term though. But I wouldn't penalize you. Very nice. Now, if there's no need for me to go through the question, I'm not going to waste time and go through the question, So let me ask the question. Is there anyone in the class who didn't get this at all? If I hear one no.
Sorry, you could start break it down.
Say it again, Papa.
You could start break it down from early.
Yeah.
Oh, yeah. That's how I want to know. Come tell someone that I can't break it down.
So you know what? I was going to say this to Sash.
Jermaine, don't tell the lie.
You said I couldn't break it down.
I never said you couldn't.
The frightening still sir. And it gets started them 171 and
Yeah.
Yeah, look back, sir, and I wonder if
I felt Sasha's pain on Tuesday. So it's not that she was wrong, but it's just the cancellation. And put it this way. Your meal is very well prepared. you may only just share it out in a one little container, but somebody who is in food and beverage may plate it differently, and you wonder if it's the same food where you cook, how they plate it differently, right? That person get that extra 5% than the one who just, share out the food. I mean, taste and everything else will be the same amount of stuff, but it's just presentation. All right. So so yes, that part is correct. So let me ask the question again, because I mean, I teach way too long for me, kill me, Is there anybody in the class that did not get the 148/6 or the 74/3 for their answer? Is there someone in the class? And if it's you alone,
Number 3, sir.
no, Christian, I'm not reach this later. Yes, over there. So what I want you to do, if you didn't get this question right, the responsibility is yours. Talk to me. Not care. Nobody said, sir, I'm alone, get it wrong, and you feel shame. Let me know.
Wrong and strong, sir.
Sir, I got it wrong, but that's how I went wrong, sir.
And that's responsible. Very good, Zidane. And I'm okay. Once you see where you go wrong, I have no problem. Is there anybody else in the class that has got it incorrect and have seen where they went wrong? All right. I've asked a question. And I'm moving on. All right, thank you. I'm moving on. Say it again, Sash.
You know what I did to double check my own working out? I did the third line twice.
And that's fine.
I did the cancellation one first, and then I did the regular way that it is the first line.
I understand. Just remember, you see, I remember Yannick and I were having a little, exchange of words, so to speak. Sir, I forgot to do all of them 5 lines here. Yan, tell me that you agree with sir and that sir was speaking the truth. See the function here, sir? And see the integration right here, sir? Isn't it one line we do for the integration, Yan?
Yes, sir.
Yeah, man. So what I was doing with you at the start of the topic was just to tell you and to show you how it is that we would have gotten there. Put it this way. The first time I baked a sweet potato pudding, it didn't come out nice, But the first time I baked a sweet potato pudding, and I was following the instruction, them say 1 cup of flour, 1 cup of cornmeal, how much sweet potato, 1 pound of sweet potato to the something, depending on what size you're making. And I measure everything to the T. And when we never have something to substitute, I call my auntie and I say, oi, may I experiment. When we put it in, she say, I have to put that is optional. And I say, all right, thank you. And guess what? You see, thereafter, we think I'm going to measure 1 pound of flour. Me just look at the potato and say, all right, them 2 potatoes there I use. Me now use more than 2. Or me I put the banana in and I just say, you know what? I do that.
You can do it from the Christmas. Thank you.
No, but the point I'm making, because you know what to do, you can use your judgment. That's the point I'm making. You can use your judgment. So I'm saying this in relation to this piece here. You know how to do the integration. You add 1 to the power divided by the new power. But guess what? How I taught you the integration, you can do it in one shot. In one day, you shot. See it so? Right here so, and you move to here so. The only thing that I'll caution you guys on, Sash said that she did the third line twice. I would have said, make sure so when you integrate the function, you double check your integration before you do the substitution, because you get most of the marks for the integration. Most of the marks come for the integration. So when you integrate the function, just double check the function or integrate it another time just to make sure. Not a double integration, Just start the question over just to make sure so your integration right. Because if the integration wrong, you know, so you have to start those only per marks. If not all of the marks. So just make sure the integration right and you're good to go. All right, number 2. Okay, that was an alternative method that I showed. Was that the question? 4x cubed, we got that question? I don't think I need the question in order.
Yes, sir, that's number 2.
Yes, sir.
What you got for your answer?
112/3 units squared.
112 over 3 unit square.
112.
Sir, and I know you decide for one the mixed fraction.
You know?
Really, sir?
112 over 3 is correct. It is correct. I'm gonna leave my answer alone and leave me alone. The answer correct. Very nice. Excellent.
Sir, nobody ask nobody if them get the other one answer. Just start workout, sir.
No, before I even reach there, so you make
I'm
question.
try it, sir. Me touch the trouble, you know.
You touch the
I
trouble?
did it, sir. I
Yeah.
did it.
No one of that. I when
Charlie.
Charlene tell Yannick said that Draper, right? When you big up goods or goods say, sir, I say to the question, I say, yes, good sir, like for real, sir. I say, yeah man. But anyway, we don't reach here say yet. We don't reach here say yet. Here's my question. Did everybody get the 112 over 3 units squared? Or the 37 and 1/3?
112 over 3.
No, sir, but I see where I went wrong.
Okay, very good. And that is the responsible thing that I want of you. You see, me now go killing if you get the question wrong at class today. If you didn't know if you do this something long before, uno do calculus 1, uno do calculus 3. So that's very responsible, very nice. Is there anyone else in the class that that has a challenge with the question, the 112 over 3 unit squares?
Sir, for me, I have the third line, right?
Yeah, you have the third line.
Yeah, and I have 42 minus, but I don't know how I didn't get the calculation for that one there. The 43.
You look at what I've done right here. I give you 2 minutes to look at what it is that I've done right here. And the reason I'm doing this, it is good when you can find your error, but if you can't, I will help you. Just take 2 minutes. The rest of you, please look at it. If you don't get it, somebody in the class don't get it, you know. But in your 2 minutes. Obviously.
Sir, I still not see it, sir.
Did you get the 42?
Yeah, I got the 42, you know, it's just the calculation for the 16 and the 40 over 3. But no,
So you don't get the 14/3.
no, my brain block right there, sir.
Question. Did you get the 16 minus 40 over 3 plus 4 plus minus 2?
Yes.
All right, good. Watch me. What should I do? The system moving slow. I'm going to do this a little different than how I did it before. All right, watch this. I did at this sash because of what it is that you're asking. What I could have done, I could have said 16 plus 4 is 20 and 20 minus 2 is 18. And then I could say 18 minus 40 thirds. But what I did now is to just put all of these whole numbers over 1, and then the LCM is 3. And then the one that is over the 16, that is under the 16 rather, 1 into this 3 goes 3 times, and 3 times 16 is 48, don't?
Yeah, I was doing that.
3 into 3 goes 1 time, don't? And 1 times negative 40 is negative 40. And then the one that is under the 4, 1 into 3 goes 3 times, and 3 4 is 12. And 1 into 3 goes 3 times, and 3 times negative 2 is negative 6.
Yeah.
So now I'm going to have 48. We have 48 minus 40 plus 12 minus 6, and that equals 14.
You know, there's something wrong with me.
What?
Yeah, no, about going. I must terminate my dinner, sir.
So go and eat, no? Go and eat, man. Where you see it now?
Sure, you always tell to put on the chicken.
Yeah.
So you got some more.
That's a true that, yeah. But yeah, but that's it. I'm happy that you see it now. Is there any other question? Anything else that you want me to look at? All right. So let us go to the trouble.
What be a man question? What be a man today? No, you go work now.
Sir, it wasn't no trouble.
It's no trouble at all. When me say no trouble, I mean no.
Work out before sir.
Charlene, tell me answer here, Charlene. I'm straight right in Charlene.
Sir, I got 82 over 3 units squared.
$82.
Yes, sir. That's what I got.
All right.
Is it 2 minutes, sir, working out no wrong?
No, say so.
Charlene.
No, say so. Let us work it through together. Sorry, somebody said something? I heard a mail a while ago saying that they got. So let me check mine, because I mean I could be wrong. So let us go. Let us go. Okay. And this question, now that I'm looking at what it is that I did, is unfortunate, because I don't teach you the ln function yet. But I gave it a rule, so you're supposed to can do it. No.
No, sir, having the rule and applying it is two different things, because we applied it in indefinite.
Same difference. But let's go. All right. So we have this function 5x cubed minus x squared plus x plus 11 over x dx. Now remember, as I said to you, like the quotient rule in differentiation, we don't have one of those in integration. So the first thing that we're going to be doing is dividing through by x. That's the first thing we're going to do. So it means that each term in, press pause. You see that one here? Each term in this numerator is being affected by this one term in the denominator. 48 divided by 3 is 16. Minus 40 over 3 are the term here. Plus 12 over 3 are 4. See that so? And negative 6 over 3 are negative 2. So every single term in the numerator is being affected by this 3, this lonesome 3 in the denominator. So with that said, it means that every term in the numerator here is being affected by this lone term in the denominator here. All right? So I'm going to have 5x cubed over x is going to be 5x squared. I didn't put in a line, so I would hope that you'll see. I just verbalized it a while ago. Minus x squared over x is going to be minus x. Plus x over x is just 1. And 11 over x is simply 11 over x. This 11 over x piece is what I believe kind of mess up Charlene, but never mind. This is a teachable moment. It's a teachable moment, and I'm happy for this moment. Watch me now. Now that I have my function the way I want my function to be. But sir, or you say have a function the way you want it. This is not 11 over x, sir. Yeah, which is the same thing as which is the same thing as 11x to the minus 1. So technically, I don't have a denominator there. So you can look at it like that. All right. Now, up here, listen to me. Me recall. I'm supposed to say recall 11 over x is equal to. All right. So let's go. So now I am integrating. It's now time for the integration. Notice when I start integrating, I lose the integration sign. I'm now integrating. Remember, I'm adding 1 to the power divided by the 4. 5x squared is 5x cubed over 3. Minus x squared over 2. Because this x is x to the first. When you have a whole number, it's just going to simply be x times that number. So 1 times x is just simply x. Watch me now. 11 over x. 11 over x is when you integrate 11 over x, you're going to end up with the natural logarithm function. So it's going to be ln x. It's going to be ln x, right? And ln x, which is what I have here, so it's going to become 11 ln x. 11 ln x, all right? And 11 ln x, you notice I put my absolute value here. Sir, why did you put the absolute value? Tell me when it is that I'm supposed to be using the absolute value again.
Rule 3, I think, or 4.
Yeah, but on what occasion?
When it's negative.
Bless up. When it's negative, you recognize that the lower limit is negative. So that's why I have the absolute value sign right here. It's very important. If the upper limit and lower limit were both positive, I never needed to put this absolute sign value here. But because I know one of the values is negative, I have to put my absolute value sign. Very important. All right. So now, so what I'm actually finding is the absolute value of 1. What I'm actually finding is the absolute value of 1. All right. Now, so having done this, I'm anywhere in the function, like I told you before, anywhere in the function I see x, I'm going to substitute the upper limit, then minus, and then anywhere in the function again I see x, I'm going to substitute the lower limit. So this becomes 5 times 1 cubed over 3, which is this term, minus 1 squared over 2, which is this term, plus 1, which is this, plus 11 ln the absolute value of 1. All of that is in the parentheses. Please ensure that you include your parentheses in the question. Sir, why? Why are you emphasizing it? It's very important because this negative sign does not only go for this term, but it affects this one and this one and this one. So you have to ensure, please, I know some of you, when I talk, you go through one eye and come through the other eye. Because I said the very same thing when I was teaching you first principles differentiation, which was like, it feels like ages ago. And when I give it a mid semester, some people didn't even change the signs. So you lost marks right there. Okay. And then again, I'm substituting my lower limit as I told you before. And you see, I have my absolute value of that. So this absolute value of -1 here, really not going to change the price of this number, because really and truly, I have absolute value of -1, and this absolute value here going to give me the same. So the value here, so, and the value here, so, going to give me the same term. All right? Watch me. 1 cube is 1, and 1 times 5 is 5, so I'm going to have this. 1 squared is 1. That is 1. ln1 is going to be equal to 0. ln1 is equal to 0. Every single time. All right? And -1 cube is going to be -1, so I'm going to have a -1 remaining here. However, -1 squared is +1. And this -1 is here. And this ln -1. ln of 1, because remember, when you take the absolute value, you drop the negative sign. So if ln1 over here is 0, that means this ln is going to also be 0. So since this term goes to 0, all I'm going to be left with is 5/3 minus 1/2 plus 1. There is no need for me to write the plus 0. Minus -5 times -1 times 5 is -5/3 minus -1/2 minus 1, and this term goes to 0. LCM here is 6. This 1 is over an imaginary 1. Whenever you see a whole number, just draw the division sign and put it over 1. All right? Put the 1 in the denominator. Because when I divide by 1, I'm not changing the number. Three into 6 goes 2 times, and 2 times this 5 is this 10. Minus, sign the names as minus. 2 times 6, sorry, 2 into 6 was 3 times, and 3 times this -1 is -3. 1 into 6 was 6 times, and 6 times this 1 is 6. I'm enclosing everything in parentheses because I don't want to get them mixed up yet. Not time to mix them up. My LCM here is 6. 3 into 6 goes 2 times, and 2 times -5 is -10. 2 into 6 goes 3 times, and 3 times -1 is -3. And 1 into 6 goes 6 times, and 6 times -1 is -6. So 10 minus 3, 7, and 7 plus 6 is 13. So I have 13, 6. We've got the middle sign same time, like here so, and here so, and here so, and here so. It's always a negative sign that is there. Now, let us work out inside the parentheses. -10 minus 3 is -13, and -13 minus 6 is -19. So I have -19 over 6. This negative sign outside here multiplied by this -19/6 will give me a +19 over 6. See here, sir? The denominators are the same. I put back the denominator and I add the numerators. 19 and 29 and 3, 32. So I get 32 over 6. And 32 over 6 is really 16/3. Shadi, without,
Yes, sir.
your error was right here, so don't.
Yes, sir.
Yeah, man, I figured. And I won't blame you for it. As Yonique says, this is what I really wanted to move into the ln function. I want to show you how to do the ln, the integration of the ln function. So guess what? That was good work, because I'm sure you got the factors, the -1/2 and the +1 down.
Yes, sir.
And I'm sure you got these 3 terms in here also. It's just the 2 ln terms that would have missed you a little bit. But very good. Very, very, very good work. Is there, go ahead, please, Yon.
Sir, you want to know what me do?
Tell
and
me.
I like instantly start mad myself. So you know how you divide through? I bring it up and brackets everything and multiply. So you see that thing that you did beside the 11? I have that outside the bracket for everything. So you know, sir, when I find the ln of one, I get 0 and me start go mad, cause me I say this can't really here I've got B.
Yeah.
That is where I went wrong.
You know, let me tell you how I feel. I mean, I have a student who says, sir, here's the plan. I'm going to show you. I attempt the question. And I look at the question and I was like, if my other groups could be as purpose-driven as this group, trust me. And the truth of the matter, I don't want to just my math class alone, so dedicated. Every one of the courses they want to have the same sort of energy. And not tell me, say, sir, teacher, I don't want to hear that. Keep up the same energy. So what I like,
All of them you can't
Sir,
keep up.
you can't do it with all of them.
No.
Yeah, impossible, sir.
keep up the same energy, period.
Like how we come class and you know.
Sure. Right now we are feed off each other and there is a class then, boy.
It's just like, oh, if we come with low energy, sir, you just leave the class. Sir, I seem so we feel when we're not getting energy from the teacher either.
All right.
Especially when you come home from their work.
Talk truth. Never mind, this too shall pass. You see, I mean, come next year, this time you're in the final year. Final year. All right, let's go. So I like the energy. So Yannick, you are not far off, because when you see this, when you take this x into the numerator, you can get x to the negative 1. Now that x to the negative 1, when you multiply it through out here, so by it, you should end up getting the same something. Real talk. You should end up getting the same something. Let me see something here. Copy.
No, sir, what I talk about is the ln with the 2 stroke and the x in the middle. That's what I wrote outside.
Oh, okay.
Yeah, so when I started and I did found the ln of 1, I must say 0. Yeah, man, my head just said, all right.
It does chip. And then you're supposed to say to yourself, say, better me start talk to myself or be my best friend like sir.
I'm just going to work out every other question.
Never mind, man. Guess what? If you see one more like this, it can't come near you. All right, look at that. So
Right,
based on what, go ahead.
We just learn, so
Yeah. So based on what you just asked a while ago, let me just show you what else could have happened. You notice I say divide through by x first, and I'm now saying or multiply by right? So in this case, I'm going to multiply by the inverse of the denominator, which is going to be x to the negative 1, right? And when I have this now, I'm going to say x to the negative 1 times x to the positive 3. When I'm multiplying and the bases are the same, I'm adding my powers. So 3 minus 1 is 2. Negative x squared times x to the negative 1. The bases again are the same, so I'm adding my powers. 2 plus negative 1 is positive 1. So we have minus x. See it right here, so? X to the negative 1 times x to the positive 1. Whoa. Negative 1 plus 1, 0. X to the 0, sir. Sir, anything raised to the power 0 is?
1.
And to the 1 right here, so? That 1 right here, so? And then now this 11 times x to the negative 1 is simply going to be this 11 over x is the same thing as x11 x to the negative 1. So you can do it either way. Whichever way you do it, it doesn't matter to me. I mean, as long as you are careful with
the other.
With this one here?
No, the other one.
This one here?
Yes, sir.
Okay, that's fine. It doesn't matter. I mean, if somebody else does it with the left-hand side version versus the right-hand side, you get the same marks. Yes, Kels.
So what I did was to put each term on the x. So instead I draw the one straight line,
you just brought them up.
What What I didn't get was the 11 ln x. That's
That's
where
fine. And I expect everybody to be at that place, because that place is a different level of 1, 2, 3, 4, 1, 2, no, 1, 2. It's a different level of calculation. So that's fine. Don't even worry too greatly about that. I mean, based on what it is that you guys did, I'm very proud. And then this is going to be a minus, and then this is going to be x squared. I'm doing this because again, because I've been teaching for so long, you know, this money now seat, and then this I say, oh me, him look if me now say nothing in the class. So that's where you work, kids.
yes, sir.
And that's fine. That's perfectly fine. That's perfectly fine. And then you move from here into here. Perfectly fine. And then over this side, you just move from here directly down to here. Same difference. All right. So now that you see how it is that we got our 16/3, you're good to go. I did not give you this question because this question is a special method. I think I gave you this question. 4x squared minus 2x plus 1 was the answer.
22/3 unit squares.
I got 16/3.
Yeah, that's what I got.
16/3, sir.
Over 3.
Okay. Kels, 22/3. All right. We need to find out where you get that 22 from. Some addition, something over right. Very good. The rest of you, I hear what it is that you're saying. Kels, start to teach up. You're
So let me get all at the top. And on top I have problem. Somewhere down at the bottom I can count.
you got the 14/3.
No.
You got the 32/3.
Yeah.
And the -4 -2.
Yeah.
All right. You have the 4/3 -1 -1.
Yeah.
Okay. So the LCM here is going to be 3. So 3 into 3 goes 1. 1 times 32 is 32. Oh, what I did right here was to say -4 -2 is -6. So this is another way of me doing the calculation. So I would have shown you where it is that I put the LCM over everything. But -4 -2 is -6. And I put the -6 over 1. And then I found the LCM. 3 into 3 goes 1. And 1 times 32 is 32. And then 1 into 3 goes 3 times. And then 3 times 8 is 6. You sure? I bet you have 6 to put it right there, so.
No, sir. What me do is I did 4 minus 2 instead of -2, -4 minus negative. That's where I went wrong.
Anybody else? Are we okay with this one? 16/3?
Yep. Yes, sir. Saw my error. One question, sir.
Yeah.
How much marks would I lose if I made like Kelvita mistake? With
As I said before,
procedure.
as I said before, you get more the marks for the integration, and then you pick up a fewer marks for the substitution. But yeah, I'd have to see the question, because they have some questions that are, you can get some of these questions for 5 marks, and you can get some of them for more than 5 marks, especially in the substitution method one. You can get for 10 marks.
10 marks.
Okay. Feeling a little uncomfortable. And let me just share why. Normally I will go through the classes and call upon the students in the class and ask them their understanding. And not really tonight. But I have my concerns. All right, so there are 16 of you here tonight. Where is Ryan? Where is Sean? Who is missing? This one is here. This one is here. Oh, I know Andrew said that he may not be coming, so I know about Andrew. 2 other students are missing. Which 2? Nesta is here? Yes, Nesta is here. All right. Okay, so let's go. Very good though, very good. As I said before, tonight, I'm going to officially show you how to do the integration of the logarithmic function. And I should be able to do the integration of the exponential function in the same breath. Right? So the logarithmic and the exponential function, right? When I move on from here, as I said to you, this is now December. And I did say to you by December 17th, when we're closing up, I really want to finish the whole syllabus by the time I close off. But the rate at which things are going in terms of me using some of the class time to go through questions and give me an opportunity to, you know, convert some of the lecture classes as a tutorial class, and I don't have a problem doing that. I would maybe the last topic, I know I will be able to start it, but maybe not able to finish, or maybe I just don't get a chance to start it. But I know I will be able to start the other topic, the applications to differentiation and integration. I know I'm going to be able to start and finish that one, because the application to integration is consider it done. Is the only thing I need to show you is just a diagram. But having shown you the diagram, the calculations to the question will be exactly the same as we are doing now with the definite integrals. So that should be a breeze. Literally, I want to teach that on a Tuesday when we have 2 hours. We are not going to start it in class and just finish it. Literally, because it done right this one. There's nothing more to it. Nothing more to it. All right, let's go. I gave you 7 questions, so this is number 3. So we have 4 more to do.
Yeah, what was the answer for the LN question again?
Something with thirds, do you know? Something with thirds. 16 thirds. No, I told them the same something. 16 thirds.
Sir, I don't know if I'm pronouncing her name correctly. Arthur Lee is asking, just letting you know that she's currently doing an exam, so she's just listening right now.
Oh, thank you, honey bunches. Yeah. Yeah, cool. Bless up. Cool, thanks. Okay, Jermaine, I am just seeing your message. Yeah, man, and that's fine. And that's fine, Jermaine. So you and Charlene in the same position, that's fine. As I said before, I would be a little bit worried if the other portions of the question you weren't getting right, but you're getting those sections correctly. So, yeah, man, proud of you, no, man. Very nice. I'm only concerned about those who are not speaking to the eye. But oh, I gave you this easy question, don't?
Yes,
what's the answer for that one?
47 over 2 units squared.
37 over?
47, sir. 47.
Oh, 47 over?
47 over 2 units square.
I get a different answer. I get 23 and 1/3. 23 and a half.
Yeah, because you do mix fraction.
I thought somebody was going to say, oh, sir, I don't know who I get that answer. Say it
Sir,
again.
I didn't get half, but I got the 23/2.
That's 23 over 2 or 23 and a half. That is the same 47 over 2, you know. I was just pulling the legs right here. So the answer is 47 over 2 or 23 and a half.
Sir, anybody ever tell us to go? No, I can't say it. I never say something, but I'm not gonna say it. It gets said recorded.
It's okay, it is recorded in Jesus' name. Next thing you say we'll go drink white rum. Sash, you're saying something.
Man, look when we go wrong, sir. I see you have 81 over 2 and that 24. Oh, wait, but sir, I don't know what to just do. LCM is 2.
Sash, man, you make sure I lick you all over the place, you know.
Exactly.
No,
That's the kind guy.
No, I'm not do nothing different. All right,
Yeah, but in break down the 81 over 2.
I have the second line right here.
Yeah, but in break down the 81 over 2 and get 40 and a half.
Oh!
Very good, Kez. And I hear Shadi coming up with it, you know. But guess what? I am showing you it is deliberate, you know. In the calculations, I'm showing I want to get you to become mature mathematically. I'm looking for mathematical maturity. That's what I'm looking at. I'm looking for. So it's the same thing. So I did the calculations like 3 different ways now. Only choose and tell me which one I'm more comfortable with. Very nice though.
But sir, my final answer is 15 over 2. You heard me, sir?
Hold on 1 minute, please. I'll come into you. Hold on 1 minute, please. 1 minute. Forgive me here, guys. I, let me not even say anything more because I'm being recorded. I just read a disturbing news and I had to just do something here. All right, so let's go. Sash. So you see, I was trying to. Normally, what I would have done here is to put the LCM over 2 and then say 81 minus 48. This time I break up this into 40 and a half. Same difference. If you want to go with the 81 minus 48 over 2, you should get the same answer as 23 and 1/2 or 47 over 2. Same difference.
No, but I'm telling you, I got 15 over 2.
15 over 2.
Talking in my new. Yeah, so I said 112 minus 64 give me 48 over 2. And 81 minus 48 give me 33 over 2. Minus that I got 15 over 2.
Yeah, here you know, but it's just that I know what the
So
problem is.
Sash, what happened to the 40?
40.
On the other side, remember you have the 144 over 2 minus 32,
81
which
over
gets, which you would get 72 minus 32, which you get 40. Over the
Correct.
higher limits part.
Sure, right, Sash. You know what Sash problem is now?
I can't do it.
All right,
The higher limits part.
the first part you're talking about. Did you get the 144 minus 64?
No, hold on.
Well, that's what you're talking about.
I'm not see it, sir.
All right, what come? Let's go. Let's start. Did you get this integration correct?
Yes, sir.
Okay, and you substituted now. So and you substitute and you got this as your function, right?
Yes, sir.
All right, cool. Let's go. So 4 squares is 16, and 16 times 9 is 144. Check.
Right.
Good. So I'm gonna have 144 over 2, and 4 times 8 is 32 minus 32. 3 squares is 9, and 9 times 9 is 81 over 2. And again, 3 times, well, not again, but 3 times 8 is 24. So we have negative 24.
Yeah.
You're all right with that?
Yes, sir.
And then now, let me just jump over to this way, because since I kind of do something different here, let me just jump over to this way. So what it is that I did here is to find the LCM. This 32 is over 1. 2 into 2 goes 1 time, and 1 times 144 is 144. Got that? No, you didn't. No, you didn't.
Sir.
Mm.
You want to I'm right. Jesus mercies. No, sir.
All right, so I think you see it now.
Sir, I'm right. 112. Where am I get it from?
I have no clue. I have no clue. I have no clue. It's 144. So that's what Kels was asking about. Raise the 40. That's why you couldn't say the 40. I need to get 40.
Yeah. Exactly. I see it now, sir.
Okay, cool. Very nice. Very nice. Is there anyone else in the class that is not seeing? Háblame. Háblame. Speak to me. All right. I also gave you this one, x squared plus x minus 7. You're asked to integrate it with respect to x with the upper limit 1 and the lower limit naught. What was your answer?
X cubed, sir.
What? Oh yeah. X cubed. X cubed plus x. Yeah, we need some sugar in my system. X cubed plus x minus 7. Yeah, where you get for the answer?
25/4.
Sir, I got negative 25
Negative
over
25/4.
Yes, negative 25/4.
Oh, because me go tell you say, oh, you make them a rush so we need to tell me just 25/4.
You see, sir, like me never take out the earpiece the way them attack me.
Me say, trust me. Very good. 25/4 is
Tonight, sir.
say it again.
Yeah, trick you tonight with them.
You see? No, and you see, let me tell you what I know for a fact. Students don't like fractions. And anything will come with fractions, only get messed up. So that's why I'm changing up the things, you know. It's the same calculation, you know, but I'm showing the different ways of doing the calculation. I'm not sticking to one method. I would not be a good teacher if I stick to one method. I refuse. Mark you.
It's what, negative 29 over
Negative 25/4. You come back, Sash? Sash?
Sir, may I look over back?
Oh, no, you sound like you're gone. I mean, in terms of the internet, so that's just tricking. The rest of you look in the meantime, please.
All right. I see the correction, sir.
Very nice. I don't know how I'm feeling. All right? Sure, all right? Understand what I'm doing?
Fair as mud.
Yeah, man. You see, I'm. Oh Lord.
My thing is just to check over.
No. I'm not worried about you, Sash. And I don't want to call the names, you know, because if I call names and say who I'm not worried about, you're going to hear say, We didn't know, man. Him having favorites in the class. But I have
But
students
you
who
like, you true, you have your favorite them.
blessed assurance, Jesus is mine. One can listen to the recording and say, who will I call upon when they never come to class? And then they can talk. And then they, and then they can talk about who are your favorite when they need come to class. No, but seriously though, guys, I know the ones who are talking to me. I can differentiate your voices. I don't have to look at my participants list to know who is talking to me. I'm particularly concerned about a few students. And put it this way. When men on earth have done their best, angels in heaven cannot do better. Is a saying that I live by. This morning I got up and I saw today was a rough day for me. When I say rough day, and then I log on the computer and never recognized that an email was sent to me 3 hours ago that I was supposed to forward something to somebody, and I was like, oh my God, I missed that email. But you know, when I write questions for you guys, and I sit down and I do the solutions to these questions so that when I come to class, it becomes more, you know, it's not time consuming for me to be doing the questions at that time. I know last week Tuesday's class was different because I didn't remember what format I sent you the questions until afterwards. So I never got the chance to do it. But for the most part, I do the questions beforehand. I'm just, I know, because I'm not, in my first year of teaching, neither my second or third or fourth or fifth. I know. And I know when students are not following. Sir, not because we don't talk in class, it means that we're not following. Rubbishness. And if that is the case, unmute the mic 1 or 2 times now and say something. But anyhow, final thing I'll say on that is sometimes in our head spaces, we have a belief that a particular question can only be worked one way because this is sir work the question one way. And they say, oh, I saw it after the question. And I am showing the variations to the solution now that 1 or 2 people are a little uncomfortable. Not that it's impossible, you know, but 1 or 2 people are uncomfortable because that's not my normal MO. I changed up the strategy because I want you guys to have maturity in your calculations. You see, if I catch you for calculus 2, me can't complain and say, did your calculus 1 teacher teach you this? It means that if I catch you for calculus 2, I would have taught you calculus 1.
Sir, stop right there, sir. Just say when.
No, man.
My emphasis on the if like saying no when.
Me notice, that's why I stop him because he keep saying if.
I'm saying make sure you are following. There are students in the class that are following. I mean, know them. I know those students. And I can almost tell you that I can't tell you what letter grade, but I know they will pass the course. I can't tell you the letter grade, but I know they will pass. There are some students in the class that if you ask me, if Mrs. Campbell come and say, Mr. Shant, how is John Brown doing? Lord Jesus, John Brown, miss. Me don't know. Let me go back and look at the mid-semester. No, man, I talk about in class. Miss, me can't tell you. John Brown, not talk to me at all. Right? But if Miss comes and say, how is Mary Jane? Oh no, Mary Jane is on top of things. You know, Mary Jane makes some careless calculation, you know, but Mary Jane, when she comes to class, she see the errors and she making her answer. But no, Mary Jane good, man. Mary Jane come to class every time.
Sasha, you know.
Sasha, that.
You say, oh no, What I mean, I tell you, no, but seriously though, guys, every class time you hear me say the same thing. On the open your mouth and on the talk, but on the way stay there, and you know what is going to happen? I'm going to take the risk of saying it, but I want to put it in the context where that it does not. It does not implicate me in any way, shape, or form. Let me use a parable. Let me use a situation, a scenario. So when the teacher gives you work to do and you do the work and teacher have evidence that you do the work and teacher know, because you come to class and you participate and teacher knows you do the work. And you go into the exam and something go wrong and you're at a 48%. And you want just a little tips. It's not 2 marks, when you're at 48%, I know 2 marks, 48% maybe work out to be about between 5 and 10 marks. All right? And you want at a 48%. You know what the teacher can do? Can say no. That people always make them calculations of and the teacher can go back and the teacher can look and the teacher can say, all right, let me award an extra mark here. Or the teacher can say, here the plan, come here. I'm going to give you a piece of work to do for me. But you see, when you know open your mouth and talk and teacher don't know what going on in your headspace, teacher go say, know what going and leave it right there yourself. And it's not a threat, But I'm saying I find that students who struggle through Calculus 1 will struggle through Calculus 2 because Calculus 2 is building on Calculus 1. Because when I get to Calculus 1, I'm not teaching you how to integrate. Neither am I teaching you how to differentiate. We're going to be doing applications of the differentiation and the integration because the premise is you already know how to do it. Last season when I was teaching Calculus 2, last 2 seasons, because I taught it in the summer also, I had a struggle because the students came to class and could not differentiate. I don't have that struggle with this group. But I'm just saying, I mean, if I refuse to call out the names and ask, Jane, you understanding? Tom, you understand? No, you guys are big people. You have a responsibility to say to me, sir, press pause, like the others have been doing.
Sir,
yes, honey bunches.
Let me help you with a parable. And it's something that happened to me. I was doing a business course. And when I was in class, I was participating and everything. The mid-semester got 95, did coursework, got 90 odd, went into the exam and froze. Came out of the exam with a D+. The teacher came to me and asked me, what happened? But luckily enough, I got enough from the courses to cover me so that I was able to pass. But she knew that something was wrong based on the fact that it was the same level of work that was happening.
Absolutely. That's the very point. So you have just articulated for me the exact point that I'm making. The exact point. That's exactly what it is that I'm saying. I don't want anybody to go and say, Miss or Sir, Mr. Shandy said, if you're not talking to the class, you're not going to feel me. That's not the point. I want to be able to say, no man, that student is understanding. And there are a few of you that I know I'm having some question signs about because you are not talking to me and it is bad manners. If sir is talking and asking you to unmute and not unmute, it's bad manners. But anyhow,
remember me.
Absolutely, I remember all the students. If you have ears to hear, please hear. Let's go. So negative 25 over 4. Yes, sir, switch it up and put negative 6 and 1/4. Now, let me tell you why I did it. I did it this way because there are times you're going to the exam and you'll get like a multiple choice. and you do the calculation and say, yes, negative 25 over 4. It's a blow the answer another day. But you need to recognize now that the answer is in a different format. And you now need to be able to convert from the improper fraction to the mixed number. Okay. Come on, computer, move. Okay. All right, do me a favor. Oh, this one is easier. You should get an answer for this one. This one you can get an answer for without getting the ln function. What is the answer for this one?
13 over 3.
13 over 3.
What is
10, sorry, 10.
10 over 3?
Okay, let me hear 10 over 3. Charlie, wait a while ago?
10 over 3, sorry.
You're a little muffled. Maybe the mic is too close to your mouth. Anyway, I'm assuming that
10, she says, sir. 10 over 3.
Oh, 10 over 3.
Sir, my voice kind of gone, that's why.
Oh, okay. 10 over 3. Let me check. Tum 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 tum. Very good. Excellent. Very nice. Is there anyone in the class who had a challenge with this question? Is there anyone in the class that had a challenge with this question?
I didn't get to do it, sir.
Oh, that's fine. When you get the document, you will see what it looks like. All right, and then say it again. We get
4 over 3.
So we do the 2 1 them on the other side. Jesus in the middle, and they have the 2 of them on the side.
We cancel them out.
Oh. No good. So you can't do that. You can't do that. You got this part here, sit down.
Yeah.
And of course, I'm going to get the substitution part. So you have to 2 over 2 is also 2 over 1 canceling, so you have x squared left. You have this.
All right. The denominator, you put the power down below, right?
What power?
The 2x squared, you put the 2 to the denominator.
No, man, I cancel out these two, you know. I'm just left to the x squared.
No, sir. Never mind. Sir, may I go put on my plate?
That's the problem. That is the problem. No, you see, Charles, you're right. You know, put on the chicken, man. All right, let's go. Is there anyone in the class? Anybody else that needs clarification on this matter? All right. I didn't give it that one, right? No, I didn't give it that one. So that's one a different one. I gave it this. I give it this one though.
Oh, so you done this one?
Oh, that was the last one?
Yeah.
Yes, sir.
All right, do me a favor. Classwork.
Sir.
I love you too.
Sir.
I love you too.
But don't like you.
You know that's a lie. You know that's a lie out of the pit of hell. All right, come. I want you to try this one here for me. Remember, the ln function is going to come out of this. Sir, how you know? Because I don't have any x to cancel off with this 3. So this 3 is going to become 3 ln x. You don't even have to put the absolute value sign. Why don't you have to put the absolute value sign for this one? Because
There are no
There's no negative, sir.
there's no negative for the upper or the lower limit. All right, so I'm going to give you 4 minutes, 5 minutes to work number 10 for me, and then I move on into that area. Cool.
Can you go back up to this Ellen question, please?
Anyone finish?
Finish what, sir? Step away.
Come on, I give a question to do for me.
Oh, I stepped away. I didn't see the question.
Let me just scroll back down to the question, please. Somebody asked me to.
Figure 5, please.
DS, number 10.
Oh, yeah, sir.
Oh my God.
Share my stuff.
Where?
That you know I'm a sir. I'm trying.
All right, try again, man. Anybody finish?
Sir, what is ln2 as a fraction?
What is who?
ln2 as a fraction.
You have to put ln2 in a calculator.
Yeah,
You know, if
give me a decimal.
right, right.
Line, sir.
Very good. So it's
So
going to give you a decimal. So some ln functions will give you a flat value, or the ln functions will give a decimal. So this answer will have to be in decimal.
Okay, that's
Mhm.
all.
Mhm.
All right, sir.
So that's the second line.
What is that about the second line, Krishna?
Oh, sir, that's it. Just want to see second line and see if you're on the right track.
Okay, sure. Like that, or you want the third line?
Yeah, man, that good, that good.
All right, cool.
Sir, question, how much DP, sir?
Say it again, Papa.
How much decimal places?
Oh, how many DPs? It's about 3, no? So
Thank you.
if they ask you for 3 decimal places now, so then you have to work in 4, and then you round off to 3 for the final answer. Then ask you for 1, you can work in 2, and then round off to the final answer. All right, cool.
Here, you see, my problem is the ln. I remember I missed that class, so I didn't really grasp it the way I should.
And that's fine. What you'll do is that is going to work out to be ln3. Sorry, 3 ln x. When you integrate 3 over x, you can get 3 ln x. And just take it from there. All right, 2 more minutes, and then I'll go. 2 more minutes. Wherever you are, I'll just project the answer. 2 more minutes, and then we'll move on. Anybody have up to there?
Sir,
Mm-hmm.
I have. Oh, my, you cancel it. You know, put that box there.
Anybody got an answer?
I got that, sir.
Very nice.
Sir, I'm gonna get one answer.
-4 and something, sir.
Yes, sir, I get a negative 4.421 units, sir.
Pop, pop, pop. Your swag turn up, turn over.
Sir, why if me have the 420 over 1000?
Same difference.
All right, so my issue is I have some parts, but my issue is with the from the which line that go upstairs.
Can I tell you your issue?
I have the 3ln2 in bracket and the 3ln1. I have that, but I didn't remove the x from the denominator for the 8/2, the 8/x and the
8/x?
Yes, sir.
So how you have to do that? So 8/x.
Yeah,
Yeah, we have 8x/x, you know.
Yes, sir.
So the x's we cancel. Oh,
Huh?
okay. Okay.
Cancel.
Yeah, the x is cancelled, so you have 8. But when you integrate 8, you can get 8x. Very nice, though. There were 2 students who gave me the correct answer. Is there a 3rd student? 4th, 5th? Very nice. That was excellent. Excellent.
Sir, you want to see me on Google I try to find the fraction form. Come here, sir. I can't a big fraction this, sir.
Decimal in this case is perfectly fine. Talk to me, somebody. Anybody?
Third question.
Yes, guys.
How you know when the
answer them in decimal?
Yeah.
I kind of was anticipating. That's why I kind of helped you out with it. Whenever you evaluate ln2 or ln the value, remember the ln1 was 0, so I was expecting, you know, well, put it this way. Most of the answers that we're getting now, we could write them in decimal form, because like the 16/3 and the 40.5, you know, we could write them in decimal form. But the ln2 is an irrational, is not a terminating decimal. So therefore you can't write it as a fraction per se. Lexton, however, gave me something as -4 and 402/1000. That's another way of doing it. So yes, you can know when your answer will be in fraction form per se, or decimal form per se rather, when you evaluate your other functions. But just to say to you, who cares, that the other answers, I was going to screw up to you, but the other answers, like the 10/3 is decimal. But it's just that we can write it as a fraction, as a mixed number or improper fraction. -6 and 1/4 can be written as a decimal 23.5, can be written as a decimal 16/3, can be written as a decimal. So all of them, with the exception of this one though, all of them can be written as a decimal. Most of them can be written as a decimal, but the ln2, you're going to find it very difficult to write it as a fractional form. So just put it in decimal form. Same difference.
All right, sir. Dumb question. And just because I wasn't here, I wouldn't have picked that up yet. I mean, I've made your session yet. The ln. So it's when you have the 3/x is when you know that you have to work the ln x.
And hold that thought. Let us get into the ln function. Hold that thought. All right, so let us spend about 10 minutes to go through some stuff here. And then I'm going to give some more questions on ln to do for me. The ones that I gave it there was just a little warm up. This is not the meat of the matter. So indefinite integrals, including the natural logarithm. See, I gave you a function. And this is, why is it called, why is this function indefinite? This question is termed indefinite.
Because it don't have a lower or upper limit.
Very good. Doesn't have any limits, low and upper. It says indefinite. Very good. So I'm factoring the whole number 3. I'm factoring the whole number 3. Are you allowed to do that? Yes, ma'am. The laws say I can factor it out, put it in front of the integration sign, then integrate the function, and then multiply by multiply out the factor term. Then multiply out the factor term. What do I mean? So I'm factoring the whole number 3. I'm factoring the whole number 3, like here, so. Then I'm going to have 1 over the 3x plus 1 dx. So once you see a rational function with a constant in the numerator, factor the constant once it is greater than 1. And then you'll have a function in the form 1 over x. Then you have a function in the form 1 over x, where x is a function, as in the example above, 3x plus 1. That is what my x is. So what I'm saying to you is, I'm teaching you how to identify the function that will include ln when you integrate. When you have a constant in the numerator, factor out the constant. Factor it out. When you factor it out, you will see that you're going to have 1 over the function left. Where the function x is going to be whatsoever is in the denominator. Watch me. So what I'm going to have is the integral of all of that to the -1. And you can look at rule 4. You see, once we have this here, guys, 1 over the 3x plus 1, and I'm integrating, think of the ln function. Think of the ln function. So this is going to become 3 times ln, what the value of x is in the denominator. But now remember, I have to differentiate the function. 3x plus 1 and then we're going to reciprocate it. Watch me. That 3 here, so, and that 3 right here, so. The 3x plus 1, or the 3x plus 1 right here, so. So why do you have it in the absolute value form? I have it in the absolute value form because I don't know the upper limit is and the lower limit. So the man may say to me, say, oh, the upper limit of 5 and the lower limit of -3. I can't take a logarithm of a negative number. So I'm going to give them something in absolute value form so that it no matter. If it's positive, it can work with the absolute value form. If it's negative, it still can work with the absolute value form. It no matter. But it's a caution myself. All right. And I'm going to be differentiating the function. What's the function, sir? 3x plus 1. When I differentiate 3x plus 1, I'm going to get 3. When I differentiate 3x plus 1, I'm going to get 3. Yes, sir, I remember it's true. It's 3. But then now I have to reciprocate it. I have to reciprocate it. So why? So the thing said. And that's why I get this 1/3. And 3 times a third is 1. So all I'm left with is ln 3x plus 1, the absolute value of 3x plus 1 plus c right here. So remember that the ln is a natural logarithm. Note, we differentiate what is inside the absolute value and then reciprocate it. We differentiate what is inside the absolute value and then reciprocate it. Now, if you want proof,
Sir, before you go in your proof, one more time for the people that run the back row of the class.
No problem. Thanks for asking. So you're given a question. The integral of 3 over 3x plus 1. I'm factoring the whole number 3. So why? Soon tell you. So let me tell you the story up front. Once you see a rational function, so what is a rational function or fraction? A fractional function, see yourself, numerator, denominator, with a constant in the numerator. So we need that constant again, just a whole number. So I don't think nothing be a whole number, you know. Could be a fraction, anything, a constant. Just don't have a variable beside it in the numerator. You're going to factor the constant once it is greater than 1. Then, sir, why you have to say it like that? Because if the constant is 1, that's what you want it to be. If it is already 1, you're not factoring out anything. You want to factor in once it is greater than 1. And then you'll have a function in the form 1 over x. And then you'll have a function in the form 1 over x. So what do you mean by 1 over x? 1 over x. But it so happens that x is equal to 3x plus 1. Oh, that's why you say where x is a function, as in the example above, 3x plus 1, yes. Now we need to factor the whole number 3. When I do that, I'm going to get 3, the integral of 1 over 3x plus 1 dx. I can write this by taking it into the numerator because this 3x plus 1 is raised to the first power in the denominator. When I take it into the numerator, it becomes 3x plus 1 to the minus 1. It says see law 4. Let me go up to law 4 and show you what I want you to see. The integral of x to the minus 1 or 1 over x. Then two form here. The function can come as x to the minus 1 or it can come as 1 over x. X to the minus 1 or 1 over x. And this one you will convert to x to the minus 1. So what is x? You keep talking about x, sir. X is what is going to be contained in the denominator. X is what is contained in the denominator. See how so? 3x plus 1 is what we're calling x. All right? Now, what we're doing is we are going to be integrating the function 1 over the function is going to be equal to ln the absolute value of the function. See it so? ln the absolute value of the function, of course, is an indefinite integral, so you have to put it plus c. But remember, they have the 3 outside. So the 3 has a 3 here. But we now need to differentiate inside the parentheses or the absolute value. I have to differentiate what is inside of the absolute value. And differentiate we get 3. I have to now reciprocate the 3. So come we get 1/3. By reciprocating the 3, we got 1/3. And then now 3 times 1/3 is going to give me 1. So that answer works out to be ln, or if you want to cancel 1 ln, the absolute value of 3x plus 1 plus c. Any clearer?
No, sir. 1 minute. So wait, so we get the 1/3?
Have we got the 1/3?
Yes, sir.
You're differentiating the absolute value function. When you differentiate the absolute value function, nearly what you get? Hello, somebody.
So you're saying that you take out the 3 and make it 1 over 3, which would be 1 over x?
I am differentiating the value, the absolute value, and then reciprocating it. That's all I'm doing. I'm differentiating the absolute value. The differential of the absolute value, 3x plus 1, is going to be 3. Because the plus 1 goes to 0. And when I get 3, I'm going to reciprocate it, so that will call 1/3. If I get 5, reciprocate it and get it 1/5. 10, 1/10. Fair enough?
Yes, sir.
And then the proof now. 3 times a third is 1. So we're going to have ln 3x plus 1. Right there, so. Let us try differentiating this. Remember, the differential of ln x is 1 over x. The differential of ln x is 1 over x.
Oh.
So I'm trying to differentiate the ln function. So I'm going to get 1 over 3x plus 1. See, Tessa? 1 over 3x plus 1 times the differential of the function. And the differential of the function is 3. So I times it by this 3. And then we're going to get 3 over 3. So we get back from the start off with QED. QED.
What that means, sir?
Quite easily done.
So you make up the one there, right? So.
No, sir. But if you write QED and get it wrong, you know, you're going to take off more marks up or something, you know, because you're wrong and strong. Right, next done. Right, next done. Next time, gonna bet, you know.
I'm so serious. Yeah.
Next time, gonna bet, you know. Next time, a jewel for him computer, you know. Next time, gone. Jesus.
Sir, boomer adrenaline, sir.
No, man, I tried to call him a while ago, man. You jump up, man.
No, man, they might be Billy a bit.
Okay.
Yeah, next time, that's it, yeah.
This is like asking for the story, them really a stick with it.
Yeah, can I tell you, Yanni? Boom. And the microphone has stick. Just never say they gonna Cuba, man, and they sleep nice and ready. All right. So you can't even answer because you know the truth, you know. All right, let's go. So now, that's all we do when we're integrating an ln function, or we're integrating a 1 over x function. When you integrate a 1 over x function, you can get the ln function. When you integrate the ln function, you can get the 1 over x function. That's all that there is to it. All right. Based on what Sir just did a while ago, I want you to look through that second example. Work through on your own this second example. Then I'm going to give you the third one to do on your own for me. Ask me any question relating to that one.
Sir.
Mm-hmm.
So the answer, another second line there?
Yeah, you know, but actually, we can cancel out that something here, so let me write on third line. Actually,
So
that two, yeah.
integrate the 5, sorry, that's why I have 5x.
Absolutely.
And being that it's just like, yes. All right, so the just I want to come and calculate class. Anyway.
Just like I say, take out in book and keep the same energy. So we give me test him and do it.
Yeah. The x negative to the -1, you make it to be ln, turn the x into the absolute, as you call it. And the plus c. Because you integrate it, right? Okay.
So, sir.
So whenever Yannick, you know.
May I try overstand what go on.
Sir, bring that down. Bring down to what sit that.
Go on here, Yannick.
So, sir, whenever the negative x is with another term, that's you do the differentiate and reciprocate or something. Is that right? That 1 over 3 is only with another number in the bottom that you do that.
So if I give another question as 1 over 3x, so integrate 1 over 3x, and the same thing you do. So your answer that be the step you get ln 3x plus c.
ln 3x plus what?
Plus c.
Yeah, that's what I'm saying. Oh, you know, small me I touch it like say on my screen. Yes, sir. No, what I'm talking about is that 1/3 beside it. The only reason why you have that, that. The only reason why you have that is because it is beside the +1.
No, it's because I differentiated what is inside the parentheses here, or the absolute value. Same difference. Any number we get right in here, so again reciprocate it. When you differentiate 3x plus 1, Yon, we get.
Wait, say that again. My brain never catch it.
When you differentiate 3x plus 1, we get
3.
When you flip 3, 1/3.
So all right, I think you understand what I say. So scroll down to the example 2. So right there, say you have it's clear that negative.
When you differentiate 1, we get. Sorry. Oh crap. When you differentiate x, we get
1.
All right. And when you reciprocate 1, we get.
To put 1.
Huh? You put 1. So when you are coming to each other, when you reciprocate 1, you still get 1. So you're really not seeing this law in this question because it was ln x. So I had to give you this example when it is just when x is greater than just x itself and x is any other function other than x. So you can see what is happening.
Oh, so even if it was a 3 alone, the 3x alone, you would still get the
1/3 because you have to differentiate the 3x.
That is what was confusing.
Yes, Sonny Bunches. Yes. I cannot pick up what it is that you're talking about hereafter. Chetty.
Yes, sir.
What one?
No, sir. Sir, I have a lot of questions. When you get an equation like that as a fraction, the first thing is to convert it. I don't know if I'm using the correct term, into how it looks in line 2.
Look on it. See if oxtail or shoulder steak or chicken.
None of them.
All right. See if a callaloo or pak chow. So what will happen is you're looking at the function and it says 3/3x plus 1. The mere fact that the function is in a fractional form, start thinking of the ln function. But sir, you not understand, you confuse me. When did they give the question with everything over x? Or we never start thinking about the fractional form because the first step that we needed to have done is to
cancel.
Right. So I'm going to cancel or divide through by the x's, the x in the denominator. And then when I'm left with my final answer after the division, then I will decide whether or not to have a function in the form 1/x. The function only works when the rule only works when the function is exactly 1/x. I can't integrate and say 3 ln 3x plus 1. The rule only works when I have 1 in the numerator and a function in the denominator. When I have a 1 in the numerator, so if I have no 1 in the numerator, I have to make the 1 being in the numerator.
Okay.
I have to make it be a 1 in the numerator before I can do anything else. So you notice how slowly I'm speaking? I'm speaking so slowly like I am just cruising. I'm going to tell you why. What Sir is doing is building. And every time I start putting on another row of blocks, I have to make sure so the mortar mix with the correct consistency. All right? So what I'm saying to you is I have to make sure that in the numerator I want 1 before I can use the ln function. Okay, Teddy, you had a whole heap of questions. So go ahead with the next one.
Yes, sir.
Mm-hmm.
Sir, all right, let me just say, it's just not connecting.
But I just said a while ago, not connecting.
No, man, I got it, you know. I'm just
Okay.
saying, like, overall, with the LN, but this topic, it's just not.
Let me ask you a question. Do you understand the definite and the indefinite form now?
Repeat, sir, sound muffled.
Do you now understand the definite and the indefinite forms of integration now?
Yes, sir.
Positive?
Yes.
Well, guess what? Me not worry about it then. You know why? Maybe the third example you've seen on the ln function. I have plenty examples to go through. You will see it. So if that is your concern, me not worried. Other question?
But sir, if I'm a master this are.
Hi. Listen, don't worry about it. Trust me, no, man.
No.
Only not trust me, no. Trust me, man. I know what I'm going to do. But the point I'm making is that I'm going to be projecting some questions, and we're going to work through some questions. And when you work through the questions, you will see you'll appreciate it a little bit more, what it is that I'm talking about. All right, you know what? Let us jump into it. So see here. The integration is as we have been doing at 1 to the power divided by the new power. See here, x squared over 2, bam. 5, when you integrate a whole number, you just add an x to it. See here, 5x. But this term, this is like a chain rule, right? It's compared to the chain rule where you have to do the things individually. So if you do this piece, and a piece and get it right for the integration, you have to get marked for them something you will do. Watch me. I recognize x to the minus 1. The only time the ln function becomes useful is when you have one of two forms. When you have a function being raised to the -1 value. When you have a function being raised to the -1 value, or when you have 1 over the function. So let's go. So this will become minus ln, the absolute value of x, plus c, sir. Why not just say ln x? I can't. Because it's an indefinite integral and I don't know what the values of x, the upper and the lower limit will be. And if the lower limit is a negative, what will happen is I can't find the logarithm of a negative number. So I have to use the absolute value sign. I have to use the absolute value sign. The only time I will not use the absolute value sign is unless I'm integrating and the upper and lower limits are both positive. Once one or both of the limits in the function is negative, I have to use the absolute value sign.
Sure.
Mm.
So in order for you to go ln, x has to be -1.
Raised to the negative first four, yeah.
Yeah. And then when you're going to find the upper and lower limit, if the upper or the lower limit is -1, you're gonna have ln with the parallel lines x. So that means that the x would be equal, the x in the parallel lines would be equal to 0. If the upper and the lower limit is like 2 or more, then it ln x, and then the x would be the 2.
Let me see if I translate it properly. I don't want to say yes, and I'm answering yes to a different question that you have. So what I'm saying to you, Only when the power is raised to -1, you incorporate the ln function. Only when I don't want to say integrate.
But
Only time. So when you're integrating, only when the negative power, or when the power is -1, you include the ln function. If the power is -2, add 1 to the power divided by the new power. Sir, so why can't we add 1 by the power and divide by the new power here? Add 1 to the power for that until we get.
it will be 0, sir.
Right, and then you divide by the new power. So again, divide by what?
0.
Right, and can I divide by 0?
No.
No, I can't. I can't. So that's why I have to use the natural logarithm, the ln function. You see what I'm saying? Only when the power is -1, you include the ln function. If the power is -2, -3, 0, you go ahead and integrate it as you normally would. Add 1 to the power divided by the new power. Then, sir, why can't I get x to the -1 and just add 1 to the power divided by the new power? Okay, let us try it. X to the -1. When I add 1 to the power, I'm going to have -1 plus 1, which is 0. Divide by the new power. But sir, you're not allowed to divide by 0. So that's why the ln function comes in play. And it comes in play only when the power is raised to -1. Can we
Sir,
all see that?
I see it more clearer when you explain it like that.
Very nice. Very nice. Very nice. Okay, so let's go. So I'm going to have ln plus c. Now, the question that Yanique asked was an important one. Because what she was doing, she was looking at what it is that I have here to say, then, sir, I'm seeing this reciprocal right here of the differentiated function. When I differentiate 3x plus 1, I'm going to get 3. And when I reciprocate 3, I'm going to get 1/3. When I differentiate x, yeah, when I differentiate x, I can get 1. When I reciprocate 1, let me get same 1. So there's an imaginary 1 right here. Real talk. I want you to do this one for me. I have 10 minutes, and I'm lending you 3 minutes out of it, so that I can use the other 7 minutes and go through the question.
7 minutes over that, you know.
Hello. If I wasn't being recorded, it's all right. I will talk to you. I will talk to you. Let's go.
Sir, you would do the square root function with the
absolutely.
With the
Yes, miss. Chitty, leave me alone.
Say that's not too much later for take on.
Oh, goodness. I bet you if when you unravel the question, you book up in about 100,000 other billion. Straight I'll go feet down.
About $1 million that for worth, sir. You not give me that.
Real talk. Trust me. I could do a million things with that. It's more than actually about $5 million that's in a journal star. Yeah. I could do me 5 million things with that.
So that can buy house nowadays, you know. So we went towards a 23 million or 24.
Talk true. 20,
Sir, that can
26.
even buy one of them root venues to where I go out now.
Talk truth. Talk truth. But it's unfair, do you know? Sorry to say it, but it's unfair because poor people money well got in it to help build it. The poor people them can't afford it because them the mortgage can reach 200 plus thousand a month. You understand? The normal man can't afford it. But our normal man money, the inner bill. So we are bill it for the rich man them. And then you go hear that, oh, but don't we build houses in Portmore? So the rich man then can't go to Portmore go live. Why we have to go to Portmore go live? And I'm not saying that anything is wrong with Portmore. I love Portmore. All right? I love Portmore.
Sir, what, not the mosquito and the hot
Oh,
sun?
Jesus, I'm if tell you. And the distance to reach home. No, sir.
But sir, my passport more so you know how far that.
A Spain live?
Yes, sir.
No, sir.
Sir, that's why I have to chunk it, man.
Sir, she don't live in Spain. She live outside of Spain. She live back at God.
Jeez, some peas and turn right.
Yeah.
Oh no.
Same spot.
Sash, I respect you. I respect you because me no say me couldn't do it.
Sir, I'm try it and come back.
after Yannick was my company, you know, sir, Yannick ditch me.
No, sir. All right. We talk about a little piece of this. Anybody get anywhere with this one?
Sir, just start the thing, no, man.
Leave me alone. Leave me alone. Okay, no, says the teacher did already down. We use the next 5 minutes to just look at that. I'm not going to speak. I want you to look at it.
Jesus paid it all to my own.
Stick to the mathematics.
Sir, what mad me in the night here?
Sir,
all of them something there. Sir, what that?
Oh, you talk about this?
Yes.
I am only showing you the calculation. You see what I do? I'm only showing you the steps to take and not taking anything for granted. So I'm just showing you the steps to take.
Sir, it's 5 minutes to 10. You can't do that at 5 minutes to 10. Now go stick.
Oh Lord, I love it. I love it. I love it. I love it. All right, so
sir,
I
where
guess
did 3/2 come from?
this?
Yes, sir. Yes, sir.
I'm adding 1 to the power. I'm adding 1 to the power. When I add 1 to 1/2, I get 3 halves. So see here, when I add 1 to the power, 1/2, 1/2 plus 1, put it in the calculator. 1/2 plus 1 is 3/2.
So you just 2 ones, 2 and 3/2.
Right. So what I'm doing right here, so let me just, since Kel's talk about it. So I'm adding 1 to the power. So this 1/2 plus 1 is going to be 3 halves. All right. So add 1 to the power, divide by the new power. So you have to divide by the 3 halves. So when I divide by the 3 halves now, in order for me to, I could tell you, say, flip it. But the truth is, when I was going to little school, that's what the people them they teach me, flip it. I mean, so flip it and just know, say, you know, you divide it by a fraction, you're going to invert and multiply. Anybody hear the teacher used to tell you that? Invert and multiply. Anybody? Or me alone?
Yes, sir.
Yes, sir.
Yeah. But why do you invert and multiply? Sometimes the poor little teacher themselves don't even know why invert and multiply. So teacher here will tell you now. So I have 3 halves in the denominator, and I want these 3 halves to become 1, because remember, all along, you know, when we get to a whole number, you know, we divide it by 1. It not change the whole number, talk truth.
Yeah.
Hey. So what we want is this 3 halves now to turn 1. How do I turn a number into 1? By multiplying by its inverse. So the inverse of 3 halves is going to be 2 over 3. So how you get that? You're going to reciprocate it. A number multiplied by another number is equals to 1. So just that other number is the inverse of the first. Sir, away at top point. For example, the inverse of 3 is 1/3. So that when I multiply 3 by 1/3, I get 1. That's what it is. So in this case, I'm dividing by so I'm converting this 3 halves into 1. So it means that I have to multiply here by the reciprocal of this. So I'm multiplying both sides, numerator and denominator, by 2/3. See to it? 2/3. 2/3. And when we do to the denominator, we have to go to the numerator. And that's how them tell us, in the invert, we put the 2 up top and the 3 down at the bottom and multiply. See, just so it will multiply. A lot of teachers don't know this. And a lot of students.
Sir, then just say that to us so then we don't get confused.
But you see the thing about it, you know. Some of you, when you finish, we have your son and your daughter who can say, Mommy, I'm doing, or Daddy, I'm doing integrated mathematics. And you them a come to. You them a come to. And this life is so unpredictable. Una may think say una go move into computer programming for argument's sake. And the job that is available is that as a teaching job. Where they say now teach and they're hungry. When you can go teach and collect 100 plus a month in time, trust me, you don't want it as a teaching job. Oh, you know, I know the employee here.
Without the qualifications, you know, I get 100 plus.
Yeah, true. But the principal will come to you one day and say, oh, I know you are in computing, you did a degree in computing. But I have a 3rd form class or a 5th form class to teach maths. What level maths you did? Oh, I did up to calculus 2.
You're not supposed to be teaching maths and doing IT.
Why?
That's the Ministry of Education rule. You're not supposed to be doing it.
All right.
Ask me why not.
I just say a word. All right. Then I'm gonna tell you a secret now. Kels, I'm gonna tell you a secret. When the ministry say that not supposed to happen, go in other schools.
No, that's not a secret.
When the principal them can't find nobody.
That's not a secret, sir.
Me hear of a situation where one somebody is supposed to teach on something and them not have it and them go to class with the maths on the book. It's like when you can't ask me a question and say, sir, then how that happened? I mean, can do the explanation. This man just take it on paper and say, I saw you go and write it off. And that's not teaching. And I'm upset about it because anybody who is teaching mathematics must be trained in teaching mathematics. We not talk about you can do maths and you can do a 1 question and you can go teach. No, you have to go through the fulsome training as a math specialist.
You have to get the pedagogic behind your name.
That's absolutely right. Because trust me, it's technical enough. The math's technical. And if you don't know, if you mess up a student in math at the lower level, you mash up the student for life. Because I'm gonna say, oh, that the subject they may hate it like a passion, right? So yeah, man, but mathematics, no, me ain't even talk because it happened. So them can't talk with them want to. So when you go in the school system, it's not pretty, it's not normal out there. But anyhow, I'm gonna send these off to you, including this one. So, yeah, go ahead.
Before you send it, can you fix your LN section, please?
Where's my LN section?
In a final answer. In fact, throughout the entire thing.
Oh, with the absolute value.
Yes, sir.
Thank you, sweetheart. So me like teaching them, student correct me feel big, you know. You think me feel away? You know, still like the normal teacher, man. Me feel big. So me telling you.
The purpose of it for CFA.
No, you're getting a little bit too smart, you know. All right, very good. You know, if only we can find the LN, the absolute value sign, you know. Let Jesus paid it all indeed. Oh, there you go. No, sir. Undo. It's not supposed to be
Senior Shan.
See.
How many topics do we have left?
Well, you know, we're actually on the mend for this one. I mean, by Tuesday, I mean, we'll finish off this one and I should be able to start my applications. Well, let me just run through and show you because I think I did some preparations.
Sir, that's where the L hospital thing then falls?
The L'Hôpital's, right. So the L'Hôpital rule is going to come into
L hospital.
Yeah, well, no, guess what, Yanni? Guess what? When I was studying this something too, me call it hospital. I one day in a class and said, I'm sir, the hospital. Excuse me, what are you talking about? L'Hôpital's rule. I said, got you. All right, so L'Hôpital's rule is going to come into the final unit number final. Remember which one that is. So unit number final is where the L'Hôpital's rule will come in. And the L'Hôpital's rule now is going back to, wait for it, limits. So it's a combination between limits and differentiation. All right, thanks for that correction. All right, so after that, we did definite integrals already. I did jump and just do the definite integrals because I was a little excited. And we did all of those. I will work with you know, guys. We do all of them something here. And then after that, we do that already. And I give you some summary. Then we have the integration of the exponential function. And the exponential function, I know you can see some double integration, but I'm not doing any double integration now. I think double integration is for the other stuff. So I just gonna have the exponential function, and then the integration by substitution, and then that's the end of that. That's the end of this topic. So I just have two more areas, two more topics under this integration to look at, and then we're done. Yeah, I'm not doing a double integration. I need to double check the syllabus again, but I'm not doing a double integration. So we just have two more areas, the exponential function and integration by substitution. And then now we move into the application. So all being well, next week, Thursday, we can start the application. The application, I may do the application of integration first, because the application of integration is so much, it's about covering a whole lot of integration now. Matter of fact, the truth of the matter is I've already introduced the application to integration. I even tell you the stories behind it. All I need to do is just formalize it. So I'll take about, I don't think I need more than 15 minutes, because the truth of the matter is I don't tell you, but we have been doing the applications of integration so far. I've given you examples of it. I just need to now formalize it, and then I'm going to spend the rest of the time looking at the application to differentiation. So maybe by Thursday of next week, all being well, which will be the 10th. No, today's which day? Today's Thursday, which will be the 9th. I should be finished with the applications of differentiation and integration, and then able to start now 9 and 7, 16, and then again have 1 week to go through the final topic. So if your exams were already in December, I would have been behind, but I'm going to tell you why. We're not really behind. It's just that I know I took a little bit more time to go through the first couple of units because I wanted to prepare you for the mid-semester and etc. etc. So a gentle massage you guys for the first half of the stuff, and then use some time to go through past paper questions, so forth and so on. But I will have 1 week to go into that thing, and that week that I have Yannick, I'll go through with L'Hopital's rule. I'll get L'Hopital's rule out of the way first, and then I do some FODE, first order differential equations, and then
I think you're gonna say FOOD, no, sir.
yeah, they're really
I'm a mind upon curry shrimp pasta.
oh Jesus, that truth, curry lobster. Anyhow, you have yourselves a wonderful rest of the evening, night. No, we now hear you. Say it again.
So, hold on, sir. Give me
Your phone drop, girl.
no?
Yeah, hearing you now.
Yeah, I was saying, I'm letting you 1 more minute of my time just for answer this. Somebody did ask if you extend the time for the
Yeah, man. Yeah, man. I will. Most definitely.
Okay, sir. Thank you.
Bless your heart. Sleep tight. Drink for Jesus, Lisa, man. Yeah?
All right, sir.
Good night, sir.
Good night. Good night. Oh.